Graphing equations lines, we have to remember that slope, one of the three definitions, is rise over run. I said we'd be using it whenever we are graphing equations or inequalities, and it is time to do that. We need to be able to look at these four different lines and identify what the slope is in general. Like if it goes up to the right, we're going to say that it has a positive slope. If it goes up to the left, it's a negative slope. A horizontal line has a slope that equals 0. If it is a vertical line, the slope, m, is undefined. Don't say no slope. I don't know whether you mean no slope means the slope is 0 or the slope is undefined. So if it's 0, say 0. If it's undefined, say undefined. So vertical lines are of the form x equals some number, and the slope is undefined. Horizontal lines are of the form y equals some number, and the slope is 0. I don't know what these slopes actually are without some points or a grid in order to figure out the numerical values of the rise and the run, but in general it goes up to the right, it's positive, it goes up to the left, it's negative. Now some people still have a hard time with this because they go, it goes to the left, it goes to the left, so it must be negative. Well, no, if it goes up to the right, then it goes down to the left. Both are true at the same time. But for a negative slope, if it goes up to the left, it goes down to the right. The first form we are going to graph from is slope-intercept form, y equals mx plus b, one of the more memorable things in algebra. M is your slope, highlighted in red, so let me change to the red pen, or actually let me change to the blue pen first, and B is the y-intercept. So I'm going to circle this and say this is the y-intercept. And that's where the equation hits on the y-axis. And then the M is the slope, and from that y-intercept, the first thing we're going to do is rise, and then the next thing we're going to do is run. So I did this in the order that I would typically do it in if I was being tasked with graphing this. So this would be item number 1, look at the y-intercept. Item number 2, from there, rise, and then run. That's the order I would do it in. So I'm going to do an example and show you how easy it can be. Then you're going to try some yourself. We're going to graph y equals 1/3 x plus 5. So my y-intercept is 5. So I go 5 up on the y-axis, up because it's positive. I plot that point. But look, I've got these axes, and I don't have the points marked out on it. That is, I don't have the scale marked out on it. 1, 2, 3, 4, 5. I'm going to go out 5 units to the right. I'm going to put a little bar. Say that's 5. 6, 7, 8, 9, 10. That's probably good enough. If I need more, I'll come back later. 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5. Okay, so we're going to put the y-intercept at 5. We plot that point. From that point, not from the origin, from that point, we are now going to rise 1. So I am now right here. Then we are going to run 3. Now 3 is positive, so I'm going to go 1, 2, 3. Now wait a minute. I said 3 was positive, but in general the slope is positive. If I go up 1, then I got to go to right 3. Why? Because this is positive. And if the whole thing is positive, it was either a positive over a positive, or, and here's what gets some people sometimes, a negative over a negative is also positive. So I could go up 1 and over 3, or I could go down 1. That's a negative rise. Down 1 and 3 to the left. So you see, just like a couple of slides ago, if it goes up to the left, it's negative. If it goes up to the right, it's positive. But if it goes up to the right, it goes down to the left. And that's what our first graph looks like. And then we would connect those. Well, that was a horrible line. So I could do this. There we go. That's approximately right. Get rid of this thing. So I'm going to try and keep this on the line so that it goes up 1 over 3, up 1 over 3, and if I did it again, it'd be there. That looks good. That looks good. See, if I plotted these points, they're still on the line, so I want to try and be as accurate as possible as I go off into the distance. Alright, now here's another one we're going to graph. Y equals negative 5x. And it doesn't have a y-intercept. So you have to think, oh, well then the y-intercept must be 0. Y equals negative 5x plus 0. So I have a point at the origin. And then I am going to go up 5 and over 1. How do I know that? Well, negative 5, if I write as a fraction, is negative 5 over 1. So from here, I'm going to go up 1, 2, 3, 4, 5, and over 1. Now in general, I just know that the slope is negative, so it has to go up to the left. I could keep doing that. If I'm going to connect them, it would be a little more accurate. There's another point. And I can go in this direction as well. Down 5 over 1, and I probably have room to do one more. 1, 2, 3, 4, 5 over 1, and then I could connect them. And there's our graph of y equals negative 5x. Alright, now you try this, pause the video, and come back and see how you did. Alright, tricked you. It's blank. Yeah, I'm actually going to do it in front of you again because it helps to see it. I'm going to graph y equals negative 1 on the y-axis, right there. And then I will get my next point, and from here I'm going to go up 2 and over 3, and it's going to be up to the left because it's negative. And then I can make a couple more of those. Up 2 and over 3. And I'll go the other direction one time, down 2, over 3, and then we can make our line. So your line should look like that. Pause it, try that one. Okay, we're going to put the y-intercept at positive 5. From there, we are going to rise 1, 2, 3, and run 1, 2, 3, 4 to the right this time because it's positive over positive, or better yet, the whole thing is positive. It has to go up to the right. One more. 1, 2, 3, 1, 2, 3, 4, and in the other direction as well. 1, 2, 3 down, 1, 2, 3, 4 to the left, and we make our line. So that's graphing from y equals mx plus b form, and a little bit of special cases thrown in. The special cases being, here they are. When y equals some number, it has to be a horizontal line. When x equals some number, its slope is undefined. It's a vertical line. Okay, next video you're going to see how we are going to graph from standard form.